In this problem, we are given the following circuit diagram, and we are to assume the op amp is ideal. We need to find the output voltage when our variable resistor R of X is set equal to 60 kiloohms. We also need to see how large Rx can be before our amplifier saturates. And we know that saturation is basically when the output voltage is equal to the max 5 volts or this negative 5 volts. Remember, because op amps operate linearly, so it will be going at this negative 5 volts, and then it will have a range that goes up linearly like this until it hits its max of 5 volts. And that's all it can do. When we look at this though, we need an equation. Let's look at our variables. So we know we need a V0 because that's what we're trying to find. We know that we need our R of X. So already I can see that it will look like a node voltage method. We're going to do this by having a node 1 right here. This is going to be our V of N because of the negative, and this is going to be our V of P because of the positive. We know that Vn is always equal to Vp. We should keep that in mind. And now we can start writing our equation. So first, for our Vn, we know we're going to have some Vn over this 4.5 kilo ohm resistor. Next, we know that we're going to have some negative feedback because this is a inverting amplifier circuit. So from our output, we're going to have some feedback that goes back into our op amp like this. Therefore, we're going to have a plus Vn minus V0, and this is going to all be over the 63 kilo ohm resistor set equal to 0. This is our first equation. We can do a few things to simplify. First is multiply everything by 63 kilo ohms. If we do this, we are going to get a 14 Vn plus Vn minus V0, which is equal to 0. If we add these together, we're going to get a 15 Vn is equal to V0. So this is our first equation. Now we need the second equation for our V of N. And we know that our V of N is equal to Vp, so that's just going to be working like that. For the second equation, we know that we have a Vp, and it's going to be subtracted from this 400 millivolt voltage because it's going in like this. So we will have a minus 400, but instead of writing 400 millivolts, I'll just write 0.4. That's the conversion to volts. So we'll have 0.4 volts here, and this is happening over a 15 kilo ohm resistor. Next, we'll have a plus. We know we have some Vp going down this resistor. Vp, and this is over our R of X, which is set equal to 0 because we have nothing else coming into it. So this is our equation. Now we can plug in our R of X. We should make a note though of this formula right here. This formula is something we are going to have to use later for part B. So just keep that in mind right here. But to simplify this one, I'm going to multiply everything by 60 kilo ohms. This will give me a 4 Vp minus 1.6 V plus Vp, which is equal to 0. When we combine like terms, we're going to get a 5 Vp is equal to 1.6 volts, or we can just say Vp is equal to 1.6 divided by 5. We're going to get 0.32 from this. So we know that our Vp is equal to 0.32. And we know that our Vn is equal to our Vp, so we can just plug this into here. We're going to get 0.32 times 15, and that's going to give us 4.8. So that means that our V0 is equal to 4.8. And we have found the answer for part A. We have 4.8 volts. Next, we're asked how large can our Rx be before the amplifier saturates. We're going to look at the formula that I underlined in blue, and we're going to make an equation for our R of X. And this will be our equation that we are going to use. We know that we need to find our V of P, and our V of P is equal to V of N. So we are just going to look at this formula right here. Looking at this formula, I'm actually going to do it in green. We have our V of N is equal to our V0 over 15. And we remember that saturation happens at this negative 5 volts or this 5 volts. So we're going to plug both of these in and see whichever one's higher. We're going to see that our V of N is equal, if we do this, to a plus minus 0.3. That just goes on for infinity. Using this, our V of N is equal to a plus minus 0.3. We can plug this into here, and then plug this into here, and see what we get for our R of X. First, we're going to plug in a positive 0.3, and then we'll plug in the negative. If we do this, we're going to get approximately 75,000 as our answer. And if we do this for the lower one, we're going to get a negative 6,818. So we are obviously not going to be using this one. We're going to be using the top one. Also, I should note that for this VP right here, the units for it is going to be voltage. So when we look at this, our voltages, because this is also going to be in volts, are going to cancel out and we're left with ohms. So our units for both of these are going to be in ohms. And this is our R of X. However, we want it in kiloohms. So we're going to do the conversion. We know that our R of X is equal to 75,000 ohms. We need to have a K, so 1K over 10 cubed. This is essentially a multiplied by a 10 to the negative cube. So we're just going to move the decimal over 3 spaces, and we get 75 kiloohms. So our answer for part B is 75 kiloohms, and that is how you completely do this problem. If you want more problems like this, there's a playlist below, as well as notes that'll help study for any of the material related to this class. If you have any questions about the material covered in this video, you can leave them below and we'll get back to them as well.